I'm Zach Ziegler, and you're listening to Oregon Rainmakers from KLCC. On this edition, I take a tour of Philomath's Lazarus 3D with founder and CEO Jacques Zonneveld. We've all heard that saying that practice makes perfect. For many medical professionals, practice that's akin to the real-world scenarios they often see are hard to come by. Schools often use cadavers or other analogs to train doctors and others, but they often end up in situations where they're doing something themselves that they've only watched someone else do before. Lazarus 3D is trying to change that. They create realistic models of organs and systems in the human body that allow learning medical professionals to practice and help skilled professionals rehearse complex procedures beforehand. They do this through specialized 3D printed replicas that respond like their real-life counterparts. They have similar texture, they bleed, and react to tasks like cauterization just like human tissue would. The company's founder and CEO, Jacques Zonneveld, recently took me on a tour of their Philomath facility so I could learn more about how the company builds this technology. We started with a mural in their lobby.
So this was done actually by a local artist who used to work for Pixar and has this giant gantry that can print whatever you want for. And this was actually 3D modeled out. So you can see all the plants are representing the light coming in from those windows and stuff.
It does. It really looks like it's growing at you.
Yeah, and this is capturing part of what we're doing as a company, which is really representing real 3D structures. Our primary goal is to help surgeons operate with confidence. And we do that mainly in two ways. First, we build products which are used primarily for medical education and training, sometimes used by medical device companies for their demos and medical education events. We also build models of individual patients built from that person's MRI or CT scan. So if you had a complex procedure coming up, we can take your data and build a replica of you.
So kind of a test run, I guess. You could have the opportunity to practice.
Exactly. We refer to them as rehearsals. So we enable a patient-specific rehearsal of an upcoming procedure. This is already being done in the state here. Samaritan is one of our largest customers, as are major hospitals countrywide, like the Cleveland Clinic, as well as many of the largest medical device companies, like Boston Scientific and Teleflex and others.
Along with that, do you see like medical schools or anything like that? Are they amongst the clientele with getting something to practice on besides? My wife is a physical therapist. She went through the whole cadaver lab scenario during PT school.
Absolutely, and that's one of the primary markets that we target. And earlier this year, we hired Dr. Jay Rosenberg, who was the head of simulation at Cornell, before leaving to join our team. And so especially since he joined, we've been increasing our output to academic medical centers, to residency programs, fellowship programs, and medical schools. And that covers everything from relatively simple models for things like learning how to suture and basic wound care, all the way up to very complex procedures that might take 4 hours or more, like a Whipple, a complex reconstruction involving the intestines, stomach, pancreas. So yeah, we can simulate very complicated procedures.
Cool.
If you have a sec, I'd love to take you through our facility. These are all our patents and stuff. So this is our final QC room. This is where things will get packaged up before they get shipped out to customers. And here you can see
hearts,
segments of the heart.
Ah.
And you can actually see all of the valves and even stick your finger in there. Wow. So you got the aortic valve, the mitral valve, readily apparent, as well as the pulmonary. And we can design these to show anatomy or to help people do procedures.
Yeah.
So
And it's actually like as opposed to like the models you see in like a doctor's office, it's a very soft, pliable tissue, just like a real heart would be.
exactly. So for when you were doing an actual procedure, a plastic model won't cut, literally. So you need something that actually behaves like real tissue. And we've done a lot of science, we'll be getting into our research area later on, to get the mechanical properties of these simulated tissues in line with what you see in actual humans. So the goal is to make a model that you can interact with the same way that you would interact with real tissue, so that so that the learnings that you make on the simulated model carry over to a real case. These are also models. These have been used a lot by medical schools like Henry Ford Healthcare Center, Cleveland Clinic, University of Miami, and others.
It's like a kidney?
Yeah, exactly.
Right.
This is a kidney for teaching how to do a partial nephrectomy, or taking out the cancer when you have kidney cancer.
Oh, so is that the little yellow spots that I'm seeing there? Is that what that is?
Exactly. So these are the tumors inside the kidney, and then the red is the blood flowing in, the blue is the blood flowing out, and then this tube is where the urine goes down into the bladder. So when you hook up blood to the red here, as you're taking out that tumor, it'll actually start bleeding. You can encounter a situation where you hit the collecting system, that's where the urine collects in the kidney, and you can have urine leaking out and have to repair that closure. So you can encounter many of the types of challenges that can occur in a real cancer case on these models. We just used these at the Cleveland Clinic for a training where they had 4 surgical robots set up at different stations, all using our models for hands-on practicals. And then in here we have our 3D printer banks. So in this room we have 38 printers, I believe. Marquise will likely be able to join us in just a minute.
I guess what would you like to know?
First off, tell me your name and what you do here.
My name is Marquise. I maintain can we call it a print farm?
Yeah.
Cool. I maintain the print farm here at Last 3D.
Yeah, we look around, I just see a handful of 3D printers here. Tell me what it takes to keep these things humming along.
So there's a fairly rigorous monthly, quarterly, and yearly maintenance routine that these go through. And also they're calibrated quarterly. Now we've changed it to quarterly to FDA standard. It's a rigorous job, but we get it done.
So what's the tricky thing about doing this? Is the material easy to work with? Is it hard to just get things printed to the level of detail needed? What's the trick for you?
I'm going to honestly say probably one of the biggest things that we run into here is that we rarely ever do the same thing twice. And so you can have an overarching process for general things, but it's very difficult to really pin down one specific thing that works, because once you have that one specific thing that works, it's a different project rolling through. There's always a different patient, there's always a different piece of anatomy, different orientation, things of that nature.
So how'd you end up in this? I'm guessing engineering or computer science background?
Yes, I went to OSU for mechanical engineering, and this seemed like a really good fit.
Well, cool, man. Yeah, thanks for telling me a bit about your day here. It's interesting.
Happy to chat with you.
This is a few test printers, so these are used to run all sorts of experiments on ways we can modify things and keep them really close to our design team, which is in the next room. Hey everybody, how's it going?
Howdy.
This is Maya, Thomas, and Jaden. So this is our design area where we will do things like take in patient data in order to design a replica of that patient, or take a set of requirements from someone who's looking for a training model or a demo model for their medical device, and then turn that into something like a toggleable design that Maya has up here.
Hi, nice to meet you.
I'm the medical illustrator here at Lazarus. So we receive CT and MRI data, and we'll go through the scans and identify the tumors. We'll measure them in our FDA-cleared software, and then export them as STLs and make a digital replica to send to the surgeon. And this helps the surgeon plan for surgery and which cut he'll start with first, as well as then on the engineering side of our team, we'll replicate these models.
At this point, this sounds like, is this more of like a custom design kind of job than like what I was told about, where there's something along the lines of a rehearsal?
Every model we create is custom made and specific to each patient, and it's a one-to-one replica. So anything that you interact with on the model is exactly what you'll get in surgery.
Having this level of detail when you're planning, it's got to be, like being able to have a good map before you plan a long road trip. Being able to look at something like this, it's a heck of a lot easier than just winging it and relying on road signs. Yeah.
Especially with livers having two veins and one artery, and all of these branches overlapping each other at different levels, it's really helpful to be able to spin around a 3D model and have a better visual perspective of the depth that you'll be expecting.
And for the folks who are listening, what we're looking at is all of these branching trees inside the liver. So you have the hepatic vein, which is coming in from the top in deep blue, and we've got probably about 40 different branches coming off of that, going all throughout the liver. And then in lighter blue, down at the bottom, is the portal vein that comes in from below the liver, from the same area that drains some of your digestive system. We have the hepatic artery in red and the biliary system in green. So all four of these large branching structures are overlapping with each other in 3D space. And whenever a physician were to encounter one while doing this procedure, they're going to have to do something to address it, either close it off or determine, where they need to cut, all these types of decisions. So having a roadmap of exactly where you're going to encounter each one of those branches is incredibly helpful in helping to prepare for the surgery. And then we follow that up by giving them the ability to actually do it once the physical model is built.
So what's your educational and professional background? How did you end up doing this?
So I'm a graduate from the Cleveland Institute of Art. I studied art from traditional to digital media, and I also took classes with Case Western Reserve University, and some of that education was rotating at Cleveland Clinic and watching live surgeries and sketching from those. So it was a dual program, learning anatomy and art at the same time to help better communicate visually body anatomy from an artist's perspective.
Really interesting to see what kind of, but I'm guessing this is what goes, stuff like this eventually goes on to Marquise, who we talked to just a minute ago. Yeah, so it's fun watching it through the whole process here. Yeah. Mm-hmm. Cool. Thank you for taking some time out of your day to chat with me.
Yeah. Thank you.
All righty. So we'll be taking you down into our research area.
All right.
And this is where we work on new material types, new methods of production, where we do a lot of rigorous testing. So we have gotten multiple grants from the NIH, and in particular, small business innovative research grants that have been incredibly helpful in the development of this technology.
Yeah.
Hey, Mike, how's it going? This is Zach, and he's doing a piece on us.
Yeah.
I thought maybe I'd take him down here.
Yeah.
You do not have to say yes, but if you would like to and be willing to talk a little about your work, that'd be great.
Yeah.
Awesome. What's your name and what do you do here?
Yeah, my name is Mike Tylinski. I am our associate research scientist, and I help develop new materials and then also look at our processes with our existing materials and find ways to try and make them more efficient.
I mean, I'm guessing this is where a lot of the real trade secrets are. So as much as you can, I mean, how tricky is it to find those materials that replicate what's inside of all of us?
It's pretty tricky. We're able to make some things that are able to perform similarly, and then always the next step is how do we then make that translate into a material that's easy to work with in production, and then make like models that will last long periods of time because clients aren't necessarily going to use them immediately. There's some really, really cool sites that we've gotten to play with, some cool ideas we found out there. It's always like cool having the whole team being able to like chat with them, let them know like, hey, we found this, and then other players will have ideas for how we might improve like production of this new material that might be challenging to work with.
And Mike, do we have any examples of either like hydrogel material or maybe that baby heart valve or something that we might be able to show them?
We do. Grab some gloves. Let's see. What would be?
So you've previously felt both a plastic material and a silicone rubber-based material. But like you said, those rubbery materials don't conduct electricity or ultrasound waves typically. So if you're going to do something which you can cauterize or do electrosurgery with, or if you want to ultrasound something, then one of these materials will actually work for you. So what we're looking at here is, I believe, a piece of the leg with an artery and vein and nerve running through it. And if you put on gloves and you feel this material, it actually feels a little bit like a chicken breast that you might have in your fridge. It's a little slimy, it's fairly soft and manipulable, but we're actually able to build this with different colors, different material types, mimicking all the complexity of the body.
Wow. Very cool. And the one that you just unwrapped here, gosh, that looks so much like the pork loin that I cooked yesterday.
Yeah, it's kind of the idea. So this was like a smaller prototype this is a section of a larger model we were making. And yeah, we've been able to make this so that it ultrasounds really well. In this particular case, the client also needed it to like puncture realistically. I guess if you're like butchering a chicken or something like that, there's like various membranes that you end up like kind of popping through or something like that. And that's part of the procedure that they're demonstrating and training with this model. And so we were able to find materials that could replicate that in addition to the ultrasounding, and then in other cases, the electrosurgery as well.
All right, cool.
Thank you so much.
Yeah, thank you for showing me these.
Thanks for coming on by.
Oh yeah, no, it's there is nothing here that is not fascinating so far. So it's cool to see. Yeah. Coming up after the break, I get to test a couple of Lazarus 3D's products. I'm Zach Ziegler, and you're listening to Oregon Rainmakers from KLCC.
I'm Barbara Dellenbach, host of KLCC's Oregon Grapevine. Elizabeth Quinn is a new member of the Oregon Arts Commission. She says her life has been rich with art in many forms.
Being able to have founded an organization, helped someone found an organization, work for a founder-driven organization, and then continue on and helping some other founders find residencies, at the whole time being exposed to learners and artists.
The Art of Place, Beauty, and Arts Funding on the latest Oregon Grapevine at klcc.org.
We're back. I'm Zach Ziegler, and this is Oregon Rainmakers. My tour of Lazarus 3D continues as founder and CEO Jacques Zonneveld prepares me for a test of two of the company's products.
Now, there is going to be a bit of bleeding. It's fake bleeding. There's no biohazard.
I would imagine so. If it were real, I'd be like, oh, so this is why we always hear those ads where it's like, we need donors for blood.
Exactly. But as long as you're careful with the scalpel, hopefully no human blood today.
Yes.
Let me know if you're squeamish, though.
A tad, but when I know that it's fake, that will go light years. I'll be fine knowing that I'm just playing with this stuff. We walk into a room where there are two demos set up on a table. The first is a replica of a male urinary system. We won't be hearing any of that tests, both for time's sake and because the microphone that I swapped to for this part mostly picked up the noise that came from a small water pump that moved water through the replica. So we pick up as I move over to the second.
So part of the goal in simulation is not just to capture the technical elements, but also the pressures that you feel in a real case. So the more that we can simulate and emulate that, and realistic models are one part of it, the better that training will be. I know some people who have done training for military applications, and they'll literally have explosions going off in the background and people like screaming at them while they're trying to do a procedure, because it helps to be able to do it under pressure.
Yeah, you hear a tale of, athletes training and they play audio in the gym of people yelling and stuff, Yeah.
So now we're going to move on to our next simulation, and this is a really critical one. This is if a patient can't breathe and you can't intubate them. So if someone chokes, gets something lodged in their throat, or is having an anaphylactic shock and can't breathe, normally what you would try and do would be put a tube into their throat, into their airway, and then begin using a bag or other mechanism to get air into their lungs. This is what you do if that doesn't work. Let's say their throat is so swollen you can't get a tube in. Then you have to make a surgical cut. So this is going to be an emergency cricothyrotomy. So this is an emergency cut that you would make directly into the throat of a patient. There's going to be bleeding, it's going to be scary, and it's going to be intense, but you only have, let's say, 5 minutes before that patient starts suffering permanent brain damage because they aren't getting enough oxygen. So you're both doing something that can be emotionally very intense, cutting into a live human's throat, and there's time pressure, and there's really real consequences. And for some ER doctors even, they might only do this once every few years. They might go through their whole training without having done one. And when you need to do it, you need to do it, and the pressure is on. All right, you ready?
Okay, here we go. All right. Gloves on.
So in the standard procedure, I'm going to demonstrate on my own throat first. You see the point right here, sort of the point of your Adam's apple? Uh-huh. If you go down below that, you'll feel a little opening between that and this ring-like structure below it. So that's where we're going to be making a cut in order to do minimum damage. Now, there are little vessels going through there, so you are going to have bleeding, and you typically can't see what's going on. So this procedure is largely done by feel. So in this procedure, you start out making a vertical cut in the throat, starting out near the point of the Adam's apple and going down about 1.5 inches. You'll then open up that skin flap and explore it in order to make sure you're getting that right spot, which is the soft spot in between the cricoid and the hyoid. Okay, so once you're in that spot, you're going to feel it. You're going to make that vertical incision, explore under the skin. And then once you've found the right spot, you're going to make a sideways puncture through there. After that, you're going to pass down the guide wire or directly use the tube if you'd prefer, lock it in place, and then begin resuscitating your patient using this airbag. So, are you ready to go?
Okay.
Cool. And just to make it more fun, typically you'll have something around 5 minutes if you respond quickly. So we're going to go ahead and start a timer here and see how we do.
Okay, I'm feeling. So I'm going to start with an incision down about 1.5 inches. We'll chop out some of the audio as I work through this rehearsal, but I'll say there was a lot of fumbling.
No, I'm not going to yell at you
No.
and say that this patient is dying, but I hope you can see the pressures that a real scenario can create.
Me finding out that I underestimate what 1.5 inches is and having to recut and generally being a little too delicate. But eventually, I hear the sweet sound of success.
Hey, 4 minutes, 47 seconds. Let's go. Let's go.
A first try, and we avoid death.
And we're going to see how much practice can help with doing some of this stuff.
Yeah. So I was pushing 5 minutes on that first one. Gosh, the amount I am sweating.
And keep in mind, the room is a nice chill 68 right now.
It is. Like the pressure, it is all pressure sweat. I can feel it.
So one of the biggest differentiators between our technology and other models available on the market is that we have that realistic bleeding. So what people were using prior was typically like a pig trachea, which is just like this, this section of sort of cartilaginous tissue from when they butcher pigs. It doesn't have any of the bleeding, and you can see exactly where you are because it's all just sitting there looking at you. So this training is completely different because we're actually capturing the ambiguities of the procedure, having the skin covering it up, having you not quite sure where you are, having to cut through the various membranes, and having that blood that's really filling up the operative field so that you can't actually see what you're doing. You have to know enough to know how to do the procedure. So to turn this over, basically we just have to do two things. We take some of this, which is a special, you can think of it as like a tape that simulates the cricothyroid membrane.
Okay.
So when you were punching through that second layer, that's what you were feeling, and that goes right there. And then the only other thing we got to do is take these pre-manufactured replacement patches. These have the blood in the skin, and it's basically just on a little sticker. So you peel off the back of the sticker, put it over the throat, and these patches are quite affordable. So you can do this training for, I think it's under $20 per event, per training. All right, let me know when you're ready for round 2.
Okay, deep breath.
Glove up.
Glove up. All right, here we go. Okay?
All right, ready to start in 3, 2, 1, go.
Again, we'll condense for time here, but the second time went much smoother.
That's a much cleaner cut.
I wasn't worried about how hard to press with the scalpel or cutting my finger, and I generally felt more confident about what I was doing. The result?
140.
All right.
So see how critical that one training could be. That first attempt might have represented someone who's never done it before. Even if you've read about it in a book, they would probably know the steps, and I was guiding you through the steps, but they might not have ever done it. So the difference between that and having done it once is 3 minutes. It took more than double as long the first time you did it.
Yeah.
And this isn't a situation where someone might have 8 minutes until they have permanent brain damage, or less, depending on how long it takes you to get there. That 3 minutes could save a life.
No, it really is like the difference. Once you've done it once, it's amazing how much quicker you get with it. And, in any industry, you see that when you have an intern or someone who has come in and you just watch them slowly build up those skills. I can imagine with this, it's very much so the same, only it's very different as far as the amount of pressure.
Exactly. So we can help de-risk that and remove pressure, because now your first case, your first dozen cases can be on a synthetic model until you're a lot more comfortable. So right now, in areas where there aren't good trainers, that learning is done over a very long period of time, watching someone who's an expert and then slowly taking on more and more of a procedure. That's why we have so many different custom developments and projects going on, because there's so many areas of medicine which, when they occur, they're extremely important to that patient, to their family, but that you don't see that often, or where the anatomy in that patient is unusual. So even the best surgical expert in the world has never seen that exact case before. Now, with our technology, we can build a replica of that specific patient or that unusual type of surgery and give people hands-on experience that they need to help them operate with confidence.
I would expect to see a company like this in Silicon Valley, in my old hometown of Tucson, where there's a really well-regarded medical school and plenty of medical teaching hospitals. How'd you end up in Philomath, just outside of Corvallis?
Yeah, I actually started the company while I was a student at Baylor College of Medicine, and that is adjacent to, the largest medical center in the world. However, I did move during COVID. A lot of meetings were going remote. I didn't particularly like Texas and the politics and some of the stuff going on there. So decided to move out here. And part of the strategy is that we have the best capital market in the world in San Francisco and Silicon Valley, about an hour flight away from Eugene. But your dollars go almost twice as far here when it comes to like retaining staff and this massive, beautiful facility that we have to house all these 3D printers and design teams and equipment. That would be literally more than double as expensive in the Silicon Valley region. So for me, it makes sense when it's time to raise money. I can fly down to San Francisco, and in the meantime, we can run our company much more capital efficiently here and in a place with really good quality of life, access to nature, a lot of the other things outside of work that I prioritize.
Well, yeah, thank you very much for showing me your company here and giving me an experience I never thought I would have, shy of some kind of, crazy apocalypse scenario.
Well, now you're ready for the apocalypse, Zach.
That was Jacques Zonneveld, founder and CEO of Lazarus 3D. This has been Oregon Rainmakers from KLCC. I'm Zach Ziegler. Thanks for listening.